Hello and welcome to Lecture 21 of Introduction to Computational Literary Analysis. So this lecture is what I'm going to call an extra lecture, which means that because we're in the last week of the course, you've learned everything that you need to know now to do your final project, and everything else is just sort of, I don't want to say for fun, but for learning something extra that might take you in a new direction after this course, not necessarily for the final project. So one of those things is a way of encoding literary information known as TEI XML. It's a long acronym. So yeah, I'm going to show you what that is right now. Here we go. So TEI is an organization called the Text Encoding Initiative that's been around for a very long time, for over 2 decades, and it has been developing a way to encode information, knowledge about text into the text itself. So this is a kind of an abstract notion, and it's difficult to wrap your head around at first, but it's based on the idea that we want to learn, we know things about a text that is not represented, things that are not represented in the plain text itself. So we know where a chapter begins and ends. We know where a sentence begins and ends. And what we've been doing in this course up until now is trying to get a computer to extract that information from a plain text file. And that's its own skill and its own method. But there's another way of going about this, which is to take what we already know about text as literary scholars and as readers, just as smart readers, and to put that into the text itself. So HTML already sort of does this to a small degree, because if, let's just imagine we have some HTML here, we could write something like EMPH for emphasis, right? If you've ever written a web page or something, you might see something like this. So Catherine Mansfield wrote a book called, and then we have EMPH here, The Garden Party and Other Stories. So here I'm just displaying the source code. I could write this in Markdown as well, and Markdown will automatically translate this, these stars here, to EMPH on the background. And that's how HTML would show you these things. So HTML is also in every web page. If we were to look at the content of this web page, if I were to open up the web inspector that every web browser has, it will tell me all of the HTML tags that are used to create this web page, and I can look at what's happening in the background. Now, so HTML, is designed to mark up plain text. In other words, to say, hey, the text that is between EMPH and /EMPH, that stuff should be emphasized, so render that in italics. And that's exactly what Markdown is doing, just in a more concise way. So this is mark up, and this is mark down. Although Markdown is, just kind of a funny name for a shorter form of markup. So each of these are ways of encoding text based on something that we know about the text. In other words, we know that this text should be italicized because it's emphasized, and we know it's emphasized because it's the title of some book. So TEI XML might look like this. So we might have this same thing, but instead of EMPH, we might call this title. Now, so title would be an XML tag, just like EMPH, for emphasis, is an HTML tag. So there are limited numbers of, there's a limited set of these tags. And the TEI, the Text Encoding Initiative, is a group of people that have decided on a set of tags to use to describe a text. Now, probably this is best seen by example. And so there's a great website called TEI by Example. And you can look at all kinds of different tutorials and examples for different forms of text. So here's one of them. This is a prose example. And yeah, so you can see that here it looks like a whole bunch of messy code, but really this is a text just rendered in a new way. All right, so we have a div tag used to indicate a division in the text. So this is a new segment of the text. Then you have a head tag, and this indicates that there's a header. Then all paragraphs are surrounded with these p tags. And then if you have a figure, a graph or a chart or something, you can surround them with figure tags. And HI is for a highlighted segment of text, or an emphasized segment of text. LG is a line group, and it's usually used to surround a group of lines, so these lines are usually lines in a poem or something else that has line breaks like this. And you have lots of other things here. So, we might have a note, we might have a title, we might have a footnote, we might have a bibliographic entry. There are lots of different ways of encoding this text, and there are hundreds of these tags. They're not meant to be memorized, but the TEI has a list of these depending on what it is that you're trying to mark up. So if I were to look up, TEI tags for poetry, then TEI by example comes up and it will show us things, like list items, line groups, and other types of ways of encoding this text. Okay, so this is useful for us in a few ways. So one is if we have a text and we already know quite a lot about it, we might be interested in making our own TEI text to share that knowledge with the world and to make it machine readable. What I mean by machine readable is that you can already start to imagine if you have text that is in a very regular format like this, where you have tags that surround it, it's easy to write a program, it's comparatively easy to write a program that will say, okay, first look for an env tag, then get me everything in between, then look for the end env tag, and store everything in between in some new variable. This allows us to extract any kinds of things that we want from the text, and we don't have to worry about the plain text being in a regular format because the marked up version is in an even more regular format. So yeah, let me annotate some of these things. So this is TEI XML. And I can extract data from TEI XML in certain ways. So let me show you some famous examples of some TEI XML. So one is the Folger Shakespeare library TEI XML. And they have marked up all of the Shakespeare plays in TEI. So if I look around here, I should be able to find a download link for these. Yeah, and let's grab something like Hamlet. So you see, if we look at their webpage for Hamlet, they'll show us that there are many different formats that we can get. Yeah, so one is TEI Simple. TEI Simple is kind of like a subset of TEI XML. Let's see if I can make this a little bit bigger. Actually, I'm just going to copy and paste this. I can download this. And then back in Jupyter Lab, I can open this. And what was it named again? It was named Hamlet, etc. Actually, you know, an even more direct way of doing this would be I can copy the link there and I can use requests to get that URL, and then I can get I can call that response. Check to make sure it came on okay. And then I can call this Hamlet TEI, and that's the text. So if I peek at the first 300 characters of this, you can see it's this XML text. This XML text, maybe if I print it, this will look a little bit better. I'll print maybe the first 1,000 characters. So there's lots of metadata here. There's metadata about who encoded this, where the original text comes from, all kinds of stuff. Why don't we look at somewhere a little bit further down there? So maybe we can look at 6,000 to 7,000. Okay, so now we have a list of all of the characters. What if we look at 10,000 to 12,000? Okay, we're just getting going. 100,000 to 105,000. Yeah, so you can see this is a super verbose way of encoding this, you know, so it's almost impossible to read here because each word and and furthermore, like each punctuation mark is encoded as something. So you have a W tag that indicates a word. Each word has a unique ID. And it also has a number that tells us this comes from Act 1, Scene 1, line 94. And it's already been lemmatized, amazingly. So was gets lemmatized to be. And it's already been tagged up as its linguistic tag, you know, so this tells us that this is a past tense verb. We have lots and lots of stuff like this. So I wonder if I wonder if we can find... Yeah, let's get a little bit more context here. So I'll get a little bit more of this text. Actually, you know what? I can read this in Jupyter a little bit easier. If I open this in the sort of built-in Jupyter system. So I'm just going to open Hamlet.xml as a writable file and write Hamlet TEI to it. And now I should have in this directory Hamlet.xml, so I should just be able to copy that, open it up. Okay, great. So looking through this, let's wait until it gets started. Yeah, so this is some really useful stuff. So I have SP, which indicates that something is spoken. Who indicates who said the thing. Speaker here also indicates that we have an indication of who is speaking this thing. So what this means is if we wanted to extract everything that Bernardo says in Hamlet and make a list of everything that he says and a list of all of his words, we could do that. So to do that, we would look for SP tags, and we would make sure that the who attribute is this Bernardo _ham. And that's because Shakespeare has more than one Bernardo, and so the Folger library has had to indicate that this is a particular Bernardo, and it's from Hamlet. So why don't we see if we can extract everything that he says. Okay, well, there is a great library, and it's called Beautiful Soup. And I believe the module is called BS4. I'm going to put this somewhere different. Great. And so I already have Beautiful Soup installed, and I believe it comes with Anaconda as well. So to parse something with Beautiful Soup, you initialize it with this Beautiful Soup object. And this is just an HTML or XML parser. So in other words, it looks for all of the tags and it generates structured data based on that. So one of the things that we have to do is tell it whether it's XML or HTML that it's parsing. So I think we do that by saying features is, and then we tell it LXML. And I believe we, give it the text that we want to parse. Now I better put this down here somewhere. So it's after Hamlet TEI. Great, and that takes a long time to run. We don't need this thing anymore because we're looking at it elsewhere. Okay, now the soup that we just got, it has all of these things that we can do with it. Lots and lots of stuff that we can do with it, but it's essentially kind of like a hierarchical object, and just like any of the trees that we work with. And so we should be able to deal with it in the same way that we dealt with any other hierarchical object. One of the neat things that it has is find all. So find all, if we look at the documentation for this, I'll get the contextual help going on here. Contextual help isn't helping me at the moment, but if we provide some kind of expression to find all. This will, okay, there we go. This will go through and look through each of the children of this page element and find all elements that match the given criteria. So one thing that we could do is find all SP tags. Another thing that we could do is find all SP tags where the who attribute is equal to Bernardo underscore ham. Is that the one? Let's check. It's not all caps. Bernardo underscore ham, like this. Yeah, now there's a quote mismatch, so I should fix the quote scenario. Yeah, and let's see what this does. Okay, yeah, this is taking quite a long time. Okay, I just made myself a tea and came back and it's done. How many do we have? 0. Okay, well that is not great. So, yeah, maybe we're getting too specific too quickly. Or yeah, maybe I forgot a symbol here. Let me try this again. It's taking such a long time because I think this is a very, very long file. Okay, actually, why don't we try just SPs? And then can we tell it to look for certain attributes? Can we tell it to look for who, and the value of who is going to be Bernardo ham? Okay, well before that, did this return anything? Okay, yeah, so it did. Yeah, so we have quite a lot of SPs, in other words, quite a lot of spoken utterances here. So yeah, if I look at the help for this again, it will tell me, yeah, I can filter it by certain attribute values. So I should be able to say who and then Bernardo ham on this. Calculate the length of that when I'm done. Great. This is very workable. So it has 19 of these spoken utterances, so SP. And then each one of these is kind of like a long list of words. So now we can navigate this thing if we want, and we can get all of the words out of this. So what is the type of one of these things? Okay, well, it's a tag. So can we do something like, what can we do with a tag? Will it let us do find all there as well? It looks like it will. So what if we were to look for inside Bernardo's all W tags? So for each SP, we're going to find all W tags anywhere in that utterance. So we're going to find all words inside that utterance for each utterance in Bernardo's. And we're going to call this Bernardo words. Okay. We have lots of them. We kind of don't want the ones that just say Bernardo. Yeah, so why don't we look at one of these again? Okay, so we don't want the ones that are inside speaker. We want one of the ones that's inside a paragraph tag. Actually, there's probably an easier way of doing that. We can just get rid of all of these if it just says Bernardo. But anyway, now we have a list of Bernardo words. And amazingly, we have lemmas attached to all of those, and we already have all of this part of speech tagged. So this is already quite a lot of data about this character, Bernardo. What if we just were to extract the lemma from each one and do like a counter on those? That would be pretty cool. So, if I got just the first, if I just grabbed one of these, can I access the lemma like this? Yeah, it looks like it's dictionary-like, so it does allow me to access that lemma. So now I can write a little list comprehension that does that. Yeah, this is already getting too complicated. List comprehensions within list comprehensions are difficult to read, so why don't we write this the long way? Initialize a new list and then say for word list in Bernardo words, because this is a list of lists we're dealing with. For word in word list, list of Bernardo words dot append word lemma. Okay, so something doesn't have a lemma, and so it's not working there. Let's see what it is that we're dealing with again. Okay, so not everything has a lemma. So maybe if we just check to see if it has a lemma, if lemma in Word, great. Okay, but that is not working. So each line, really this is Bernardo lines. Really I should call it that. go through each of these lines and then go through each of those word tags. Yeah, what if we were to do it like this? Okay, so I'm definitely on the word tag there. So I should be able to get the lemma out of it, but it doesn't like this construction. It doesn't like that construction for some reason, so why don't we put this in like a try except. So a try except means try this thing, and if that doesn't work, do this other thing instead. So what if we try to do this, and if that doesn't work, just go on to the next one. And let's not print out everything. Okay, that's a little funny. It just keeps on doing that same thing. Oh, right. I just forgot to update some of these variable names. Okay, so these are all of the lemmas that Bernardo says. Great. Why don't we run a counter on this? So I'm going to import from collections, import counter. And then look at the most common. What if we look at the most common 50? Okay, so already you can see just how powerful this is. I mean, this is just a taste of the kinds of things that you can do with TEI XML. And of course, there are so many other things that you can do, not just get all of the lines that Bernardo says, but figure out based on whether a Shakespeare character is a king or a queen, get the number of times they use modal verbs or something. So you can get lots of very specific information out of these TEI XML documents. So there are hundreds of these documents out there. I'll just show you a few of them very quickly. All right, yeah, so one of them is Jane Austen TEI was created. It is, none of these. It's created by UNL, the University of Nebraska-Lincoln. And it will take some looking around to find this. Yeah, so here we go. It's github.com/cdrh/data_Austin. Yeah, and I'll post a link to this somewhere, but these guys at University of Nebraska-Lincoln did a really great job at making these TEI XML files for all of the Jane Austen novels. So this is a really great resource if you're interested in working with the Jane Austen novels in kind of like a structured way. So there's lots of metadata about all of the characters. This person is married, this person is of a professional class, this person is a member of the gentry. It's really, really richly marked up. So this is made by literary scholars who know these texts very intimately and who want to share that knowledge with you in a kind of machine-readable way. So one of the neat features of this, for example, is that it has not only who said something, so you can, of course, extract all of what a particular character says, but whether or not what they said was allowed or not. So that means that sometimes, you have this free indirect discourse function, where you have Jane Austen sort of narrating what someone is thinking. And this comes across in these allowed equals false statements. So Mr. Bennet was so odd, a mixture of quick part, sarcastic humor, and etc., that the experience of 3 and 20 years, so on and so on. This is something that comes from a narrator, is about Mr. Bennet, and tells us something about this character in a kind of free indirect discourse sort of a way. So if you're interested in quantifying the free indirect discourse in some of the Jane Austen novels, a lot of that work has already been marked up for us. Same thing here with chapter divisions, so this says that it's chapter 2, and the type is a chapter. We can get some of this out of a plain text by looking for certain headings like, chapter 2 or something, but this gives it to us in a machine-readable way that is much more reliably extracted. So what that means is, if you're interested in the kinds of things that happen in the beginnings or the ends of chapters, we can look for markers like this in the TEI XML, and we can be able to extract it in a much, much more reliable way. So that's Jane Austen. You can also find a lot of these from my Open Editions project. So I have an open source project called Open Editions, and we collect a number of these projects and we work on them to enhance the metadata as much as we can so that these might be machine readable. So we have one of Dubliners, for example, which is something that we worked on. We have a TEI XML file for all of the works in Dubliners, and some of my former students have helped out with this a little bit, and we've enhanced this as much as we can. So for each mention of a person's name, we've marked up, oh, this is a person's name, and this refers to a particular XML ID, and we have a list of these elsewhere where these people are kind of described. And we also say that if someone says something, we're going to mark up who exactly says it, so that later we can use this to analyze it in really sophisticated ways. So as an example of that, if we look at Ulysses, which is one of the novels that has been analyzed the most fully, in the analysis directory, I'm able to come in and extract the speech using Beautiful Soup again from all of the characters in Ulysses, and come up with something like this, which is that for each chapter, this is who speaks the most in each chapter. And you get an idea of the homogeneity or the heterogeneity of certain dialogue patterns in certain chapters at a glance, by doing just a few lines of Python based on what we've already done marking up this stuff in the TEI XML. We can also do TF-IDF through PCA analysis and look to see what characters speak the most similarly. We can get even more sophisticated things done using word embeddings, which is something that we hadn't really talked about in class. But another thing that we could do is look at the statistically dissimilar words from each character to sort of give us an idea of the linguistic fingerprint of each character and the kind of thing they talk about. And here's one, too, just for fun. We can look at how readable each one of these characters' dialogue is, based on the US grade level needed to be able to understand their dialogue using a kind of metric like the Kincaid metric. This is all stuff that you can find in the NLTK. So Stephen Dedalus is one of the headier characters that often thinks and talks in a sophisticated way, and these characters are you need like a kindergarten level, grade level to be able to understand what they're saying. And we can do topic modeling and lots of other fancy things. And this is all because we've done a lot of work in the background marking up all of this stuff to make it machine readable. So we have a number of texts here, a lot of stuff by James Joyce because that's who I specialize in, but also Anthony Trollope, also George Eliot, and there are plenty more TEI files out there. So a great resource for this is the Oxford Text Archive. So if you look through this, you can find TEI XML tags, texts that were created anytime in the past like 20 years. So if I look for Robinson Crusoe, for example, I can find a TEI XML version of this. This is SGML. It's a little similar, but yeah, this is a great repository for TEI XML text from just like a huge range of British and American literature. So if you're interested in extracting certain types of information from a text or encoding information that you already have about a text, TEI XML is a great place to start with that. And to learn more about this, go on the TEI website, check out TEI by example, or check out Open Editions, which is a project that you can get involved with yourself if you want something to do for, for an extra DH project. And there are detailed contribution instructions if you browse the Open Editions website. All right, so that is an introduction to TEI XML, just as an extra. And if you have any questions about this, feel free to reach out either on Zulip over the course of the next week or via email. I'd be happy to answer any questions you have about the TEI or working with TEI data. All right, that's it.